In last lecture, we have seen the functions of air intake system. In that, very important part is turbocharger. Now we will see how exactly this turbocharger functions. Okay, come. See, this is the construction of a turbocharger. It has two impellers, 1 and 2. Okay, to understand turbocharger, we will see two-stroke engine. Okay, in last lecture we have seen four-stroke engine. This is a two-stroke engine. What is happening here? Air intake naturally. Okay, naturally it is taking air inside and it is throwing it out. So first is what is called power stroke, where blast is happening, and then exhaust strokes. So it is a two-stroke engine, but it is not efficient because there is no sufficient amount of air for complete combustion of this fuel. And that is why in old days vehicles were having very less mileage. Because of turbocharger, around 30% of the efficiency of all engines has gone up. Now let us see construction. There are two impellers, 1 and 2. One is called compressor wheel, another is called turbine wheel. Okay. Now turbine wheel, let us see. Turbine wheel, this below one is turbine housing and this is turbine wheel. From here the flue gases are entering. See, exhaust gases are entering and those are rotating this impeller or turbine. Now very important concept. How? Okay, that is important. You will ask me how it is rotating. The hot air is rotating the turbine. How? See, if you heat the air, what is happening? The molecules are getting heated. Okay, the air molecules are getting heated. When molecules are getting heated, its energy goes up, energy level. And what happens when energy level goes up? So because of high energy, the air molecules are traveling very fast. Okay, like our kids, they have very high energy and they are roaming around or running very fast. In the same way, if these molecules have high energy or heat energy, those will move very fast. Because of that movement, now this is a confined space, right? In this confined space or closed space, those molecules are bombarding where? On the impeller. That is the only thing they can move. Otherwise, everything is rigid. And that is how those molecules are bombarding, and that is how it is, because of that flue heat, the turbine is rotating. It's very important. Now, see, because of hot air, this impeller or turbine is rotating. Okay. Now, at the same shaft, we have fitted what? The compressor, from where we will suck in the air. Same shaft. So, because of that energy, it is sucking the fresh air. Okay. And the important thing, the speed of this impeller is very high. I'll tell you. See, it is exhaust is going here, it is rotating this turbine, and at the same shaft it is rotating what? The compressor, and the compressor is connected here and it is sucking air. See, it is sucking air from here to here. And here what is this? This is our cooler, intercooler, because see, here it is sucking air, right? Because it is called compressor. As the air is getting compressed, its heat will go up. Okay. In the same way, like I told you earlier, if we compress the air molecule, its heat will go up because it will get less energy and it will bombard to the walls, and total energy, because of that energy, the heat will go up. Okay. And because of that, we need to cool that. Otherwise, what will happen? Half stroke. Okay. We just saw before the piston reaches TDC, it will blast. So it will be half stroke. the power stroke, we will not get full power stroke. That is the reason we need to cool the air, and because of that this intercooler is placed. See how it is functioning entirely. Okay, now you will not observe the smoke because complete combustion is happening. Intercooler is there, I just told you. Complete combustion. See, hot air is becoming cooler, cold air for the engine, and then it will be out. Now this bypass is provided because if the amount of air, exhaust air goes up, it should not damage the turbine or damage our turbocharger. That is why bypass is provided. In case if there is more flue gases, then it will bypass our turbocharger and it will be saved. So this is how turbocharger is functioning. Now, advantages of turbocharger. What are the advantages? More air, more fuel can be burned. Okay, and more power. 100% fuel. Whatever fuel is there going in the chamber, engine chamber, it will be burned fully because we have ample amount of air or oxygen for the complete combustion. Then better air or fuel ratio at all speeds. See what is happening if speed goes up or speed is less. What is happening? The air will be less if speed is high. Okay, and that is why we need turbocharger, which is pressurizing, compressing air and providing it to the engine. So if air volume is less for the high speed engine, you will see smoke coming out of the engine. Then more air at lower speeds, better fuel consumption. Okay, then self-compensating at high altitudes. If high altitudes are there, to self-compensate. At high altitude, we have cold air. Okay, or the amount of oxygen is less. If you go at high mountains like Himalayas, okay, it's a high altitude. The amount of oxygen in that air is less. If amount of oxygen is less in the air, we need to compress more air in the engine for the complete combustion because we need oxygen. That is why it is compensating at high altitude. Then pressurized air manifolds reduce combustion noise. Okay, combustion noise it will reduce. Then utilizes energy from exhaust gases. This is very important. See, any which ways we were throwing out those gases. The same energy, the heat energy, I told you how heat energy is converted into rotational energy of this turbine. The same energy used to get the air or suck the air, compress the air. And that is why the efficiency of the engine has gone up by 30%. Okay, then next, fitted in housing or intake manifold. Okay, it is fitted in center mounted. Then a bundle of tubes to circulate engine coolant. Okay, engine coolant is circulated, then pressurized hot air passed over this element, aftercooler we are talking about. Then heat from air absorbed by coolant. Obviously we need to absorb the heat because turbocharger has heated or compressed that air, and that is why its temperature has gone up. Drops the temperature of air from 300 degree or 149 degrees Celsius to 218 or 103 Fahrenheit or 103 degrees Celsius. Cool air means more oxygen. We have seen cool air means more oxygen, more fuel burning and more power. Okay, now very important question. Can you guess at what speed this turbocharger is rotating? Can you guess? See the number, you will be amazed to see that number. Turbocharger speed is 70,000 to 1 lakh RPM or 100,000 RPM. Can you imagine such a high speed? And that is the reason it is able to suck the air at very high speed and we get ample amount of air for the complete combustion of fuel. Okay, special attention required to air filtration. Okay, that is the reason we have bigger filters. If you go and see the engines have very big cylinders above it, and those are filters. Okay, because this requirement is high, volume is high, we need bigger filters. Then choked air cleaner may cause seal leakages. If air chokes because of this high speed, there will be leakages. Okay, pre-lubrication of bearings, care and maintenance we are talking about. We need to pre-lubricate the bearings, otherwise because of high speed it will go bad. Then idle engine for 3 to 5 minutes before stopping. It happens. If you stop the DG, it will run for 3 to 5 minutes at idle speed, because this turbocharger is at high speed and we slowly need to bring down that speed. Otherwise, this will open your housing or problems will occur. It will damage the impeller. Then prevent load of exhaust system. Then periodical inspection of radial and axial plates is important because of its high. This was all about the turbocharger. In next lecture, we will see air exhaust system. Okay, thank you.